Welcome to Module 2, Lesson 1. So, now we're in a different realm of math we're going to be talking about here. We're going into the realm of time. Now, time right off the bat is going to, for the most part, be something that cognitively we understand pretty well. But when we apply it, sometimes that's when we get a little confusing. So, kind of to talk about this a little bit, we're going to be talking about how we can explore that time is always continuous. That time as a continuous measurement. It's always happening, it's always going on, it's always existing. Way before I existed, time was happening on, and time will continue long after I'm gone, in a sense. Same thing with all of us. So that's kind of one of the biggest ideas that we're going on here. Like, for an example, you could have a stopwatch on your phone. And with that stopwatch on your phone, you could, well, start a timer. And now on that timer, you can see things are ticking down. 4, 5, 6, 7, 8 seconds. That is a time that is continuously moving forward. Now, I can go ahead and push the stop button, if it works. And now it has stopped at 16 and about a half seconds. Now, even though that this time has stopped, does that mean time in the world has stopped? The answer to that is no. Time has not stopped. Time is continuous. The timer has stopped, and I have stopped counting here, but time in general is still moving forward. So just kind of keep that in mind as we're going on through this. So when you fall asleep at night, time doesn't stop. It just keeps on going. Just because you're not paying attention, time's still going on. It's not like in 20 minutes, it's only been 5 minutes. In 20 minutes, it's been 20 minutes. So just kind of keep that in mind. Time is continuous. It's always going the same speed. And we're not going to go into the super like quantum science with time and whatnot. We're going to keep it pretty relative here. So time is a constant. It's at the same speed. It's going at the same rate continuously. We will always experience time the same way. 1 second is 1 second. 1 minute is 1 minute. 1 hour is 1 hour. 1 day is 1 day. 1 month, 1 month, 1 year, 1. You get the idea. That's not going to change. Time is relevant. It's always happening. It's always occurring. So I think I've repeated myself in that one. But now we're going to kind of jump into the new idea we're talking about. And it's how we as humans interpret time. Because without interpreting time, time means nothing. And so as we interpret time, we have created these things called clocks. Now there's two types of clocks. There's the type of clock that you can kind of see right here with the shorthand, the longhand. I've got another example right here. And then you have the digital clock, the one that says 1:32 on your watch or on your phone. Now, it's important to be able to read both types of clocks there. Because the digital, that's just more convenient. It's being able to get, oh, what time is it? Bam, I know what time it is. But knowing how to read a clock like this, an analog clock, is also very important because it's a great example how time is always continuing from what we can from a physical perspective. So, give an idea of this. We have a clock here. Now, I'll use this one for right now, and when we get to the minutes and hours hands, we'll talk about this. So, on a clock, an analog clock, you have 12 o'clock at the very, very, very top. Now, we'll talk about that in a second, because I know some people are wondering, why do we not start at 1? Why don't we start at 1 right there? And we'll talk about it in a second. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, the reason why this is the case is because at this 12, it's one of those things we don't say or show, but on the clock, the spot that represents 12 is both 12 and 0. And that might be the question of like, wait, what? This is the part about time that can get a little confusing, is elapsed time, how things continue to move forward. So let's say this marker is going to represent the minute hand. So if I start, let's try that again. I'm going to say we have an hour hand and it's pointing at the 2 o'clock. I'm going to say the shorthand is hour. We'll talk about that a little bit more in a second. So the marker is going to be the hour hand. So we know that in 1 hour, there are 60 minutes. Now, looking at this, you might wonder, where's 60? Because 1 hour is when that minute hand goes all the way around the clock and back up to the top. That's 60 minutes. And once again, you're like, well, I don't see 60 on here. How do I know what 60 is? And that comes to being able to recognize what's in between all these numbers. Now, in between the 12 and the 1, there are 4 little marks. Between the 1 and the 1 has 1 as well. After the 1, it's got 4, a little more, and then the 2 has 1 again. And 4, and then the 3 has 1 as well. Now, this is where groups that we talked about in the previous model come in handy a lot. If we're talking minutes, minute hand, here to here is one group. 1 to 2 is another group. 3 groups, 4 groups, 5 groups, 6 groups, 7 groups, 8 groups, 9, 10, 11, 12 groups, so on and so forth. So, in each one of these groups, there are 5 minutes. So if I'm at the top right here, that's 0 minutes. So it goes 1, 2, 3, 4, and then at the 1 it's 5. So in one group, there are 5 minutes. And then there's 1, 2, 3, 4, 5. So at the 2, that's 2 groups of 5. And you continue on. So if I get to the 3, that's 3 groups. And how many are in each group? 5. So if I'm starting here at the very top at 0, and my minute hand went from the 12/0 all the way down to the 3, how many minutes is that? Well, it's 1, 2, 3 groups of 5. So it's 15 minutes. Now this continues all the way around. This is 15 minutes. And then you can just skip count by 5s. 20 minutes, 25, 30, 35, 40, 45 minutes, 50, 55, 60. So the mark is 12. It's saying that there's 12 groups of 5. And 12 times 5 is 60. Which is interesting, because did I just say that the 12 represents 0? I just said that, right? I've said it multiple times. Now, once again, this is one of those things that can be a little confusing about time. So the 12 represents more than just 12 and 0. It actually represents 0 and 60. Now, it's a little weird on that one. And when we throw the hour hand into this, it will make a little bit more sense. It's kind of making smaller groups, and then when you make it all the way around the clock, it's making a bigger group. And I'll explain once again in a second. So this is 0 or 60. Because if you look at a clock, if you ever watch that even at a digital clock, you'll see like 1:59. It's 1:59. When that 59 goes to 60, you actually never see 60. You don't see 60 on a clock because it goes up to the next group. You go from 59, 1:59 to 2 o'clock. Because when you get that 60, it bundles it up, ties it in the bag, and puts it on the hour train, basically. So if I'm at 1:59, that means I already have a bag of 60 minutes set off the side, and that's my 1. And the second I fill up another bag with 60 minutes, I tie that up and I set it with the other bag of 1s, which now I have 2 bags of 60, which is 2 hours. Now, once again, we'll talk about this a little bit more in depth, but just kind of keep in mind, it's groups of groups in this sense. So these are groups of 5 going all the way around, and if you make it all the way around, that's one group of 6 to make an hour. And so you make a whole bunch of groups, and you get all those groups, you get 60, total of 60, and you take that group and put it in over here. And now you have that one. So once again, a little kind of confusing. It's kind of the concept that time is continuous. So I just realized that this looks like 0, 1, 6. So that's a dash. So it's 0 or 60. Now, I'm going to show you this clock now. On this clock, the long arm, the one right here, this is the minute hand. The hour hand is the short one. So for this clock, red is short, long is minute. So kind of keep that in mind. So the best way I can kind of help myself remember this is that the red one is shorter, right? You don't see it super well. Sorry, it's mirrored. It's kind of having, which way I'm pointing is kind of messing me up here. So the minute hand is longer and it's pointing past the big numbers, right? So it's not saying, the blue one's not saying, it's saying, I don't care about these big numbers here. I care about these little itty bitty dots all the way around on the outside. So it's reaching farther because it's trying to get that farther information. Now the short one is hour because it's pointing at the one closer to the center, which is this big number. So going off of this, I can go ahead, change this clock up to, let's say that. And typically you start with the hour hand and you look at the hour. So you look at the red one. The red one is sorry, right here, and it's pointing at the 1 because it's pointing at the one closest to it. So we know the hour is 1. And then you can look at the one right here, the blue, and this is the minute hand. It's on top of the 2, but are we looking at 2? Is it pointing at the 2? No, it's not. It's pointing past the 2 right here. And it might be a little tricky for you guys to see right there, but that is 10. I know that because each group of 1 is 5, so 5, 10. So we can remember it that way as well. So that would be 10. So this would be 1, 10. The time is 1:10. AM or PM, we haven't discussed that yet. Maybe later. But we can continue and change this up again. We can change it to right here. Now once again, we look at the hours first. Hour is the short one, and the short one's pointing to the inside. So what one is it pointing at? 10. So it's 10 something. Then you jump down to the blue one, and you follow it all the way down to the outskirts of its town, and find out that it's pointing at the 40, or really, really close to that 40. There you go. And once again, if you need to double check that, you can just skip count by 5s. 5, 10, 15, 20, 25, 30, 35, 40. Just going around that way. So it's skip counting in a circle, basically. Kind of keep that in mind. Now, I can keep messing with this and going around, but before we move on, I want to talk about one more thing here. If I was to have the hour hand right here at the 10, this hand actually does move. It doesn't move very fast. It moves slowly enough that if you're looking at it, it doesn't look like it's moving. You can look at the minute hand and you'll see it move a little bit every now and then. But the hour hand moves so slowly, it looks like it's standing still. Now, I'm going to go ahead and throw this all the way back to like right here. So now that is saying it's like 10:02, since it's 1, 2 dot. So 10:02. So as this one is circling around, going all the way around, this hour hand over here is actually moving as well. It's just going very, very slowly. But I do know that by the time the minute hand is halfway around, that means the 10 is halfway to making 11 full groups. So the hour hand is basically saying, I'm at 10. Where am I on here? I'm halfway, so that means I'm halfway to 11. So if I have the minute hand go all the way around and is almost at the top, saying I'm almost making another group, that means the hour hand would be really, really, really close to making an 11th group or making an 11th hour, if that makes sense. So just kind of keep that in mind as we go forward with this. Now that we have a better idea of how to read time, and once again, we'll practice it. Sometimes analog clocks can be a little tricky. That's why a lot of people use digital. But I just want to kind of give some examples of how time can be helpful to us. It can tell us how fast somebody is going, who's faster, who's slower, if something's getting done in an effective amount of time. As a teacher, I can give expectations and like get this done in 10 seconds. If I say get this done in 5 minutes, you've got some time to get it completed. But if I say, yeah, 5 seconds, you're like, I got to get this done fast because I only have 5 seconds. That's a lot less time. So, in addition, I could also ask something along this line. I could say, I'm just going to use some random things here. Tim he was racing with his friends, and he completed the race in 15 seconds. Tim's friend, Bob, was running with him, and he finished this race in 13 seconds. And I'll be using SEC for the word second. So just kind of keep that in mind. Tim and Bob had another friend that was racing with them named Sam. And Sam ran it in 18 seconds. Now, I could ask a question off this and say, who ran this fastest? Who finished first? And now, before you answer that question, I do want to recognize something. Typically, in the realm of math, we think the higher number means bigger or better. Now, it really depends on what you mean by that. And let me give you an example on this. If you're trying to win a race, if you finish the race in 20 minutes, it took you 20 minutes, right? If somebody else did that same race in 10 minutes, who finished the race first? The person with less time is the person who finished first. So if you're doing a race, the time with the smallest amount is the person who finished first. So just kind of keep that in mind. So going off this, if Tim ran the race in 15 seconds, Bob finished the race in 13, and Sam finished in 18. If they all started at the same time, who finished the race first, or who finished it faster? The answer to that would be Bob, because he finished it in 13 seconds. And then who came in second place? The second person to finish is the person who finished with the second lowest time, which would be Tim. And then who came in last? It would be Sam. Not by much, only by 3 seconds. Not that much longer, but it took him the longest to finish. So, just kind of keep that in mind now. Now you could also ask a question of how much faster did Bob finish the race than Tim? And then you do the difference there. Bob finished at 13, Tim finished at 15. How many seconds are between that? 2. So if Bob and Tim started racing at the exact same time, Bob finished, and then 2 seconds later, Tim finished. So Tim finished 2 seconds after Bob. And you can do the same thing with Tim and Sam. Tim and Sam ran at the same time. Tim finished at 15 seconds, and then Sam finished 3 seconds later after him. You do the same thing for Bob and Sam as well, and that difference would be 5. But hopefully you get the idea on this one. So I know this lesson's a little bit longer. It's kind of a long introduction, but hopefully it's kind of helpful to you. But a big thing we're going to be talking about is like who came first, who came second, who came third, fourth, fifth, last. How much faster did somebody do something? Kind of keep that in mind. How much faster, or how fast, or what is the difference? So kind of keep it in mind. We're keeping in mind comparison of times. So just kind of keep. This is going to be what's probably going to be on your homework, on your practice, on your problem set, and stuff like that. So just kind of keep that in mind. If this aspect is still a little confusing to you, that's okay. This takes a little bit to figure out. But once you get it, you get it. You'll look at a clock and just know it instantly the time. It won't happen overnight. It won't happen in a week or two, but over practice, you'll get it. Now, with that being said, I'm going to go ahead and finish up the video here. Hopefully this was helpful. Hopefully I didn't confuse you a little bit too much there. But hope you guys have a great day.